This video is brought to you by Skillshare. More about them later in the video.
This a big spaghetti monster, as people like to call it. I think the machines are trying to tell us that it's time to sleep.
There was definitely a little bit of a pushback for the digital engineering. They sort of saw you as like the black sheep of the room.
And I was like, guys, we'll get crazy if we keep doing this. We need to do something smarter.
It's coming, and it's coming pretty fast, and I don't think people realize how fast it's coming.
I think some people are afraid that we will be taken over by this kind of automation tools of machine learning thing. That I don't believe.
So we're just here with Anand. He's obviously worked for a company called Victor. He's actually a little bit of a different type of engineer. He brings both the digital side and the structural engineering side and trying to bring it out to the masses so it makes digital engineering closest to everyone. So Anand, if you just want to give a quick introduction of yourself and what you actually do at Victor.
Yeah, so I have about a decade of experience in automating engineering processes. I have done this in structural engineering, but also in two production companies we had, so a bridge building company and a French building company. And currently I'm the head of growth at Victor. And Victor is a software platform made for engineers so that they can automate their workflows, create tools that also less tech-savvy engineers also can use. And we provide a whole system of sharing those tools with their team or a bigger organization.
So how does Victor actually differ from, say, someone who can just write the standard script, say something in like a Colabs or something? What benefits does Victor bring to the table?
There are like several benefits. So if you think in a Python script alone, you have some challenges sharing that with other people. First, because a lot of colleagues probably don't know Python. So what we enable is that a single engineer can make a web application with a nice user interface and put it online. So they can share that easily with their colleagues, with clients, and they use those applications to automate their workflow. In any engineering workflow, there are all kinds of software packages involved. So FEM packages, geotechnical packages, Excel sheets. So we enable those engineers also to integrate those software packages and connect it to the web application. So you can automate like a big part of your workflow. On top of that, we provide a system. It's a cloud environment where you can find all the tools you made that your team has like available, and there all your colleagues can come together and collaborate, create different designs and projects, see the data, and admins can also manage access to the platform, see all kinds of usage statistics. So we really deliver a complete system for building web applications and sharing those applications.
Sounds like it's a bit like what's another software like Grasshopper, which has those different plugins, but a bit more probably user friendly because you can do the interfaces in the back end. Is that sort of what Victor offers?
What you see in Grasshopper is that you connect all the kind of nodes and you run different logic blocks and you get a result, which is mostly a 3D model in Grasshopper. So it's often a 3D model is like the end result. What we do is enabling people to connect different pieces of logic with Python and build a user interface on top of that. So you can imagine that if you have like a big Grasshopper script, there are not too many people that can use it. It's a big spaghetti monster, as people like to call it. And maybe a very simple thing, it's easy to use, but not everyone can use it. So there's like a scalability issue. So not everyone can use it. And on top of that, sharing that script, it's quite difficult. You can put it like, for example, in a shared folder, but then you don't know what happens. So maybe you'll start making copies, changing that. And then before you know, there are like 10 different copies of that Grasshopper script, of that Excel sheet, or that Python script, of the Dynamo script, whatever you're doing. But when you put like an interface on top of that, so it could be a Python script or a Grasshopper script or whatever, and with Victor you make this interface on top of that, and you make a web application, you're full in control of who are using those apps. So you know that those people are using the right version of your code. You know that people that use it are authorized to use it, so it's not that people can take the script and take it home, so it's protected, your IP is protected, and the interface is user-friendly, so it's really a web application with sliders and buttons, and you see a 3D model, and you see the most important values that you want to show to the users. So it's like making any kind of script user-friendly at the end.
So what type of software are you currently linking to at the moment?
Basically, it can be any kind of software. We have like a generic way of integrating with software. But because we are most active in the construction and engineering industry, we see that a lot of clients are integrating, for example, with Plexis, CSI, ETABS, all kind of FEM packages. it could be anything between like really replacing a simple Excel sheet up to very complex applications. So we have clients making, for example, apps that fully automate the design of dikes. Or, for example, there's a tunnel being built between Germany and Denmark, which is the longest submerged tunnel in the world. So it's 18 kilometers. And the structural design of that tunnel is also fully automated in a Victor app. So you have really a wide range between really simple things that are like the boring stuff you don't want to do on a daily basis to really big optimizations you can do on the platform.
I've seen in the past where we've had big optimizations on like a really big building. We had over 1,000 columns in a project, and late in the project, the director said, "Oh, we need to add an extra 2 kPa per floor." And they went, and so we had actually, unfortunately, how we had set it up, we had an Excel sheet, we had it linked to Revit as well. So, but we were able to change those 1,000 columns from design changed, redesigned, and spit out and remodeled within an hour or so. But it's because of the way we had set it up. But it would have been quite hard for anyone that hadn't been using that Excel sheet because it was quite complicated. Where you could see it'd be quite powerful if you can set up the correct web app, get the same benefits, but have that access to anyone in your company.
Yeah. That's the whole purpose of making apps and then making it accessible to everyone.
So have you done any case studies on how much improvement people have been seeing through your software at the moment?
We have a lot of cases. There's a quote of a client I like to share always. It's from a client that's working this app that designed dikes. And he says, having the luxury of having the tool that saves you 80% of the time quickly becomes your new standard. So it's really big impact. And some things you cannot really measure in time or in money savings, although there are money savings. But you can also imagine what typically happens in a project, which is a big risk, is that, as you said, things change during the project. It's the nature of the project. Things change. And when you have like a flexible design system, as you described too, where you can change it quickly, you're always able to find the best solution quickly, without suffering any kind of delays or having to pay a price on maybe doing something rough and using a lot of material to kind of compensate for the lack of time you have. So it reduces risk. It enables you to have your deadlines, and on top of that, it saves you material too, because you made a lot of optimizations. So, for example, we have a client that they do piling systems, so foundations on piles here in the Netherlands. Everything is on piles because the soil is very soft. What they did is, first, they made an app to, for example, calculate the bearing capacity of the piles and make a pile plan. So what happens is their client, they arrive with a kind of a draft of what they want. They have all the knowledge actually to do this analysis, but they don't have the time because it's a quotation, so they're not able to spend too much time. And that means that they're not able to, they're less competitive than they could be if they will do this analysis and offer a best solution. So that was their motivation to make an app. So now they calculate like the whole pile plan automatically, and each new client that arrives, they basically offer them a better and cheaper solution than they had before. So that alone is a reason for winning more tenders and getting new clients, because they know that you will go there with a plan and they will come with a better and cheaper plan for you. So it's automatically saving you money. So it's you can save at all sides. You have like benefits.
You get a lot of benefits, just not only be able to offer a lot more options. So the client says, what happens if I do this and this? And you can give a lot better advice as well, saying, well, no, this is the exact impact, instead of going, it's going to be somewhere around here. So it gives you a lot better feedback as well. You started off as a structural engineering engineer as well. So what brought you into a company like Victor, and probably moving a little bit away from that traditional structural engineering more into the digital space?
So I'm part of the founding team of Victor, so I'm kind of part of the history also. So it's maybe nicer to share how Victor was raised, to say it somehow. We're basically fresh from the university. I did a master in aerospace engineering, focused on structural engineering. And we were quite used to use MATLAB for all kind of optimization. So I was working in composite materials, which it's like calculation-wise, a difficult material to calculate because properties are different in all directions. So it automatically become matrices by 6 by 6, and it's all a lot of math. So we're kind of used to this. And then we finish our master degree and start as a group of friends, basically offering services, structural engineering services in the industry. And once we had a project, and we were shocked because from being like in a university where you get all kind of optimization techniques and then going to like the field, we discovered that there was like tons of boring, repetitive stuff you had to do as an engineer. So just to give you an example, there was like, we had to analyze their vessels. They're vessels for oil production. So it's like a floating extraction facility. And on top of that vessel, you have a lot of truss structures, basically, with pipings and all kind of system. And those vessels are designed for 25 years. And after those 25 years, they don't want to throw the vessel away, of course. They have to do a fatigue analysis. And the thing they do is they have to analyze all welds of all the top structures to see how much damage they have in fatigue and then propose solutions. And they were doing this by hand. And we're talking about thousands of welds you have to check.
Yes.
And we could not believe this. We started doing this a few weeks, and then I remember that evening we were sitting outside drinking a beer. And I was like, guys, we'll get crazy if we keep doing this. We need to do something smarter. So we started really thinking about how we can improve this and start automating stuff. And in the end, we automated a lot, and we were more competitive than a company in India, which has like a lower salary. So they're probably equally capable, but they were doing this old process by hand. And we did like, in a few hours, we were able to do like 20 times they were able to do, thanks to this software we are developing for that project. So we thought, that's interesting. It seems that this is like where we can really excel in comparison with other people. So we started doing that, and at a certain moment, the oil price was really bad. It dropped from 120 the barrel to 40, I think it was 2014. And we had to shift to a new sector because we will not have clients in the offshore industry anymore. There were no projects. So we started making a bridge building company, composite bridges. There, it's basically the same. You get a quotation, you have to do a structural calculation report, some drawings, then you have to build a bridge, then they want to change something. We start automating, and we sold this company. And one of the things that the client wanted the most was this piece of software that was able to automate everything, because they didn't have an engineering firm in their company, so they were a production company, and they needed to do this calculation without being dependent on us. That was like the first time someone told me, okay, I like the tools you make, but you need to make it like really
user-friendly,
idiot-proof to see it in some ways, really robust, and that, okay, we start doing this. And at the same time, we were doing another project with a lot of foundations for high tension poles. And there it kind of clicked really, like, okay, this automation stuff, there is a market for automation. And we started doing this more and more and more. We started doing this in building companies for tanks, for silos, for all kind of stuff. One of the biggest clients, and still a very good client of ours until today, they approach us and say, hey, look, guys, we love the web applications you're making. They're very useful, but we want to make them ourselves. And that was really like a pivot point in history.
Yes.
When we decided to open our own tools we use to make web applications and start a pilot project with them to see, hey, can they use the tools? Is it not too difficult? Of course, at the beginning it was, but we started improving. Now we have a solution that's really easy. So that's the history behind Viktor. Now it's used worldwide. So we have clients all around the world, also in Australia. So Simi Group is using the product there, for example. But we work with the largest engineering and construction firms in the world. So Jacobs, Mock McDonald, McDermott, Vinci Constructions, Arcadis, they all use Viktor for doing this. And if I look back, the whole reason why we end up making this company was because we were frustrated about how boring engineering could be, basically. So that's what we want to solve for people. And that's also like our slogan. I have the t-shirt. So it's really automate the boring, engineer the awesome. And that's where we stand for.
It's very much been for a long time. I think when I started, but when you started as well, there's a lot of repetition stuff that with the rise of computers, why are we doing column load rundowns? Like, why are we calculating a column over and over again? Where you're spending all this time in this mundane tasks that would then also can lead to big errors because you're copying results from here to here and here, and you just copy a couple of wrong numbers and then you got this error through your whole system. I think this automation helps with your engineering, but also helps with your safety as well, because you don't make those errors by linking up everything properly. Any engineering firm you've worked in, there's that pool of Excel sheets, but a lot of times someone will change it, modify it, you don't know which is the right one. There's not the same level of like access control or quality control for those spreadsheets like you would have in like a proper software like GitLab, where you got versioning control. So you're sort of offering that through the hands of the people that can actually do it and supply that.
One of the important reasons, like they are making this web application for calculating the tunnel between Germany and Denmark, is on one side they want to optimize and have the design flexibility. So if something changes, recalculate everything. But the other side, they have 90 sections of this tunnel. They're 200 meters. They all have different conditions. They calculate, I think, 300 load cases for each section. The amount of data that's flowing through this project is tremendous. And the chances of making an error, if you do it like on the manual way, it's like growing exponentially. So they really need this central place, this single source of truth where you can access and say, okay, this is the information we use for this design. And I have seen that going wrong in some companies that just, you used the wrong Excel sheet. Oh, and then it kind of explodes.
Yes. Well, it's probably one of the most amazing projects that you worked on so far, either with Victor or even before Victor, that you're most proud of.
Victor is a bit my baby, so I'm super proud of it.
Victor, it can be Victor. It can be Victor.
It's difficult to choose because we have been involved in such nice projects from different things. So really, this tunnel is of course amazing to be able to work on the automation of the longest tunnel. I was not involved with, but we are in a team doing that. Also, these dike reinforcements. We have also some amazing projects with machine learning. I have no favorite, but it's amazing. I have been able to see what's happening around the world in all kinds of projects and how things are evolving. And I see there's like an acceleration coming. So there's more and more people learning to code, more and more people developing tools.
Because for a long time, especially when I was working at bigger different firms, there was definitely a little bit of a pushback for the digital engineering. They sort of saw you as like the black sheep of the room, the person up there making all these little tools, to help them out, not seeing the great benefits. But I think a lot of people are starting to realize that, especially with like machine learning is out there, which you get a little bit of access in programs like Grasshopper, so use it. But does Victor also integrate some tools for machine learning in their tools as well?
Victor itself, we don't have like domain knowledge in the product. So basically, we see ourselves as a facilitator so that people can turn their logic into web applications. We don't want to be in the domain of clients. So we're very clear about that. Of course, it's a Python-based product, and Python, it's really strong on exactly that, machine learning. So all the Python libraries that you could use for any purpose, but also for machine learning, you can use in Victor. We have a few cases also of clients using machine learning for their projects. And we ourselves are also developing some tools. So we are using, for example, big language models. So the most famous is ChatGPT at the moment, of course. It's like the new buzzword. But we are using that to help people create apps. So it's like a personal assistant to help you create apps faster. So we're developing that, and then we already have some impressive results. We have seen, for example, companies doing foundations. The foundation company, they are also using machine learning. So, for example, for them, they have basically two big price drivers. At one side, you have materials, which is basically the amount of piles. That we can calculate very well with like classical engineering, to say it somehow. So we know how to calculate that. What we don't know is how fast can you stamp those piles in the ground. So you have these huge machines, boom, 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 stamping those piles. And that is something with normal math we cannot predict. What they did is putting sensors on the machine that record how fast the piles are driven. Based on that information, they trained a machine learning model, and they used that together with historical data, together with the soil borings of CPTs, and they combined the data to see how fast that project will run. So they can now calculate the ideal optimized pile plan and how fast they can do. So they don't do an optimization on materials anymore. They do an optimization on costs. So it enables them to go further. We have another client, McDermott, for example. They work on a lot of piping systems. And they have these huge diagrams with all kind of pipes and valves and sensors. I don't know how people read this. It's like black magic for me. And they also trained some machine learning model to recognize all the symbols and to do verifications. So they have a process where you have like more junior people making those, and you have the more senior people checking that. Then all the like approved, checked documents and the modifications that were made are fed to the model. And now they're able to do like the verification super quick. So you put like the PDFs with these diagrams, and in a few minutes they get all the errors. Hey, you need to put a spool piece here. This is going to clash. It's really incredible. What I cannot even imagine where we will be in 10 years with this kind of stuff.
You're mentioning ChatGPT with the rise of AI. So obviously with your tool as well, you can start to link in some of those big MMLs and machine learning tools through Python then with your system. Do you see that significantly changing the way we engineer, how to model engineering happens today with those type of tools? Because at the moment they're very limited in what they do, but it feels like there's a big shift coming. I'm not sure your feelings on that.
I think there is some impact, but we're far off reaching the potential it has. So I think in 10 years, 20 years, you will not even imagine the stuff we're doing with machine learning, and this will definitely change the way we're doing engineering. But I think some people are afraid that we will be taken over by this kind of automation tools of machine learning thing. That I don't believe. I believe that in the same way automation is now helping you to free you from the boring things, analyze more scenarios. It's your friend at the end. It's helping you to do like things quicker and giving you time for the real deep engineering questions, improving the process, analyzing scenarios, talking with stakeholders. What do you think about these different solutions, and really coming up with a better solution? So I think it will be a helping hand more than a replacement of the classical engineering.
Maybe eventually AI may take over, but it's going to be a really long time because there's just too many variables. And what we bring to the table is problem solving, right? We solve problems.
So I think, it will take over some stuff we are doing now that we think, no, computers are too stupid to do that. And no, they will be smart enough to do that. But I think our work will shift. So like at the beginning, you had people drawing on paper, and then they were drawing on AutoCAD, and now they're making 3D models, and then they're making BIM models because those tools empower you to finally do more. And I think kind of the same will happen. You will have new roles, new responsibilities, and those models, machine learning models, will do 50% of the stuff we're doing now. Yes. Yeah, for sure. But that doesn't mean you're like, but there's still so much room for improvement. I mean, we're far off using our full engineering potential.
Do you feel there's any underrated skills at the moment that engineers should really trying to be getting in their repertoire of skill sets moving forward?
Yeah, I think definitely coding. So, So it's funny you say it. So I think still some people think, oh, there you have this guy with the scripts and whatever, I think that's really underrated. So coding, it's really an enabler for you to achieve more, to use your knowledge more, to also push the boundaries of what they're doing. So if now you're automating your own task, go beyond that and see, can you help other people automating stuff?
This video is brought to you by Skillshare. Skillshare has an amazing online learning community with premium content that is updated on a regular basis. It is also ad-free. When you mostly think about Skillshare, you mostly think about some of those soft skills such as photography, art, and the like. However, they also have many hard skills that also help you with some of the content that we're talking about today, where you can learn Python programming. They also have other courses if you are looking to build up those more managerial skills, especially in remote teams, through a video content series that I've been watching by Claire Liu, where she goes into the best practices for managing remote teams and how to be a leader in the changing world of remote online working.
The way you're currently communicating doesn't have to be that way, that there's a way to communicate in a remote team that feels easeful.
Engineers are lifelong learners, so it's really a place where you can help improve your skills, assets, and your benefits to your company or the goals that you want to achieve. With the first 1,000 people to click the link in the below description or use the code on the screen, we get a free month free trial on Skillshare. I hope to see you over there and keep learning. And now let's get back to the content. What are some of the problems that people fall into when trying to automate these type of situations for these type of tools?
First one, which we discussed previously, is not knowing what's the proper tool for the job. The second challenge people start facing is that they want to integrate different parts of their workflow, data, software packages, and one of the challenges is how you do that. So sometimes you don't have the technical expertise to do that. Once you start making tools for more people besides yourself, you face also new kind of challenges that are not always technical. So, for example, how do you make sure people use your tools? That's something we often don't think about us as engineers. We like to solve problems, and then we have this tool and with this nice interface, and then we think it will happen automatically, but it doesn't. Of course, having a nice interface, which people can use, user-friendliness, clear descriptions, not technical descriptions. Hey, this is what my tool do. This is how you use it. But I think most important is that people see value in the tool you made. There's not such thing as a tool that is not ready. Your tool is never ready. So make a draft of the thing you want to do. Make this interface, basic functionalities. Go and present it to different people. Get feedback. Get feedback of those people. That will help you really create something people appreciate. And at the same time, they will feel part of the process. They will feel that you are making a tool for them, and it's not you trying to push this tool to them and they're busy with their life. You make them part of the process. So that's a very important thing. And when you take that really to the next level, you have to think about really distribution. So what is my system to share those tools? You really need to have a system. So putting tools in a hard drive, that's not a good system. So something I see often is that people have really ambitious plans, which is great. So think big as you want, but start small. Really start small and improve it in time, improve it with feedback, and don't start building something big, and then I think those projects have the tendency to fail. So when you just start growing the project and not validating that idea with people, then it's like it's failure, guarantee of failure.
A lot of time when you're the one building tool, it's really easy to go, the benefits is here. You can see what the benefits are going to be, but then what you got to realize is someone's got to hit the budget. It's we're not here to be free. The tool may be amazing, but where you need to build the case study up is how many hours are you going to save the engineers? So therefore, if I have a budget of this, look, we can save 10, 20, 30 hours on projects. So how much cost savings do you actually get? What is your ROI? What's your return on investment? Also need to make it usable, like you were saying. If no one uses it, you might think, oh, it's really obvious. You just click here and here and here, and you just do it. Somebody else looks and just goes, I have no idea this. It's gobbledygook. It looks like nonsense. So it's very easy to get down that type of path. If you were to start over learning Python again, what would you recommend a lot of engineers do to try and learn a tool and that programming asset such as Python?
Programming is one of those things that you need to practice. So there is no magic book, no magic video that will teach you this, unfortunately. But if you are starting with zero, I think you can take any basic Python courses. So you can go to the free courses of Code Academy, of the paid version, which is very interactive. And once you complete that, and you know what an if statement is, what a for loop is, they're some basic axioms of programming, functions, maybe a bit of what is a class. Then you have to jump into doing something that's valuable for you. Try to define the logic of this to make some kind of flow chart. And then just go to internet and see, hey, how can I do copy results from Excel? How can I do this? And there's a lot of material available. The only thing you need to do is practice and practice with things that are helpful in your day-to-day work. Because I know some people that started into Python and then they start learning Turtle and dit and that. And I say, is this useful for you? No, but I'm just learning Python. And then, no wonder you don't get value of it. You need to go to really challenge yourself to solve like those issues that are hurting you on a daily basis.
Python is very much like a language. Is if you don't use it or you don't try and use it, you never learn how to use it properly. And programming is very much similar. And you'll also find that programs like Python, which is an object-based system, it doesn't matter what object-based system it is. Once you jump into the other language that is similar, you'll be able to use those same tools that you've built in Python in the other object-orientated softwares as well. So it's not even a loss, even if you change to a different type of software. Their skills are still very beneficial because you're just speaking
totally
computer language.
It happened to me too. So I said I learned MATLAB at the university, then I learned Visual Basics. Now don't do that. But then going from MATLAB to Python was not that hard at all. So it's a bit different, but the basic principles are the same. So it's like, okay, maybe going from Dutch to German, the two languages, they're quite similar and you can learn the other language if you put a little of effort in it. Programming, more than knowing all the commands and everything, it's more a way of problem solving you have to learn. So how do I solve this problem? What are the steps to solving this problem? So that's like the mental exercise. I will say 3 phases in Python learning. So one is the really basic stuff, so that you can find everywhere. So any basic Python courses will teach you the same, the if, for. Then you have like practical stuff that all engineers could use, like doing stuff with Excel sheets, automating reports, processing data, making graphs. So everyone, doesn't matter which field, are useful. But then it gets really specific. Then you have about how to integrate with ETABS of CSI, of Diana. It gets really specific. And there will be not like one dedicated courses that will bring you from beginning to end for that specific niche in which you work. So you need to kind of navigate and find the thing that's useful.
You're working with a lot of big companies around the world now with Victor. What are you finding is probably the biggest engineering challenges out there at the moment that's going to really is causing issues for the industries globally?
You see that the big need to make better use of the materials we have, to really make the most optimal use of the materials, to reduce carbon emissions, because either you believe on that or you are limited by the government and you have like their things
you have to
do.
follow it anyway.
One way or the other you have to follow that.
Yes.
So you see that I think the whole society is each time more aware of that we should do better, and I think engineering companies have that challenge to meet those expectations, to deliver on that promise, because at the end I think engineering construction companies a huge impact on how things work in the world. You can make a bridge with 30% less material, for example, if you do your best in the engineering side. And the issue we have is we have a lot of knowledge, we are getting more knowledge, but time is our constraint always. And that is one of the biggest challenges I see, is that we're not making full use of our engineering knowledge, of our potential, because of the lack of time. And there I see automation like the solution to beat those challenges.
Like the construction industry, I think concrete alone is about 10% of global emissions, total global emissions. So you think about that, if we have a 20-30% reduction, that is a significant change on a global level.
Yeah,
it's huge. You're talking percentages globally, which is really huge. And there is big moves. I don't think a lot of engineers realize the actual complexity of how carbon emissions and the embodied carbon and all that is going to have on an industry long term. It's coming, and it's coming pretty fast, and I don't think people realize how fast it's coming. I think by 2050 we've got to hit net zero in the construction industry globally. And when you think about that as a problem, is we don't even know where we're currently sitting and even how to do that. I think at this point, like, how do you replace concrete? How do you get concrete to zero? There is places out there like Zero Concrete and stuff which are investigating that to try and help solve that. But it's not just waiting on a scientist or physicist or someone else to solve that problem. We also need to look at from our end, how can we design better? How can we optimize? How can we create lean structures safely as well? And that's where your automation and probably using software like Victor and stuff and making sure you're not making those copy and paste errors where you needed the additional factors of safety, we really come into the industry moving forward.
to automate, you can optimize, you can get better results. At the end, it frees you from the repetitive stuff, and there is where you can really think about innovation. So we are so sucked into doing the same stuff, doing the report, meeting the deadline, that we don't free ourselves of that and really think about solutions that will have like a 30% change in the stuff we're doing, not these little increments. And that's the thing I want to see, so that we kind of give this to the computer and we really start thinking about things that will generate like big impact in the stuff we're doing, like new ways of designing, new ways of building, like new materials, and we can spend our creativity in making those big changes.
I think that's exciting though, but I don't think a lot of people get scared by that, but it means that you get to do better and more efficient structures as well. And a lot of people are scared to go outside their bounds. Like they get stuck saying, this is how I've always done it, so therefore we should always do it like this. And that's not really the excuse or an argument for it, because it's just saying, I don't know how to do any better and I don't want to learn really. And that's, it's not really the right way to going about this.
I think it's also a thing of generations. So of course you grew up with a certain way of working and you're used to that. It's not easy just to change to something new. But I see the new generation, they grew up in the university with Python. They're used to automating. They get much more things at the university, machine learning, control system, all kind of like more advanced things. And I see like the big change makers in design are the younger generation at the moment. They are creating the tools, they're creating that. And what we need to give them as like more senior persons, senior management, is give them the trust and the budget.
You think about all the amazing buildings, I'm just thinking in Italy, right? Those guys were probably in their 30s when they were designing that and being the lead engineers on those type of buildings, where now you probably wouldn't be into your 50s or 60s until you're a lead engineer, have got so much more experience. But also the automation tools is also giving people can learn a lot faster. If they use the tools correctly, they learn quicker how a structure actually behaves in the mechanical systems and how loads flow, as opposed to the day when you had to use hand paper calculations, which would take forever to try and get that same level of repetition and learning how systems behave. So I think people have got to realize that you've got to open up, and that's the only way we evolve is by changing and not sticking back in the same old way that we were doing everything. Thank you for taking the time. It was definitely interesting and especially seeing your tools and how they can definitely benefit a lot of stuff, because I have seen some of those problems, especially like you were saying, the giant spaghetti of programming when you get into something like Grasshopper, right? Grasshopper is like what I'd call engineering light or programming light. But the problem is it only, in the end, when you get a really complex thing, it's only something that you can use because it's very intimidating, where having the web apps and having it all in the back end definitely makes it more user-friendly for everyone. So it's definitely a really good system that you're putting together there, Victor.
Yeah. It was a pleasure to have a chat with you. Also, it was super interesting to hear what you are doing. So I don't know if you have been to a podcast, but it's sure a podcast worth to tell your story. And besides that, it's just encouraging people to take that step, to get into the coding, to get into automation. And if you want to try Victor, it's free. You can create and share apps for free.
I'd just like to thank Anand for taking time for having this interview, and hopefully you did enjoy that. There'll be another video here about how you can learn Python scripting that I'll link up here. And if you're interested in support the channel, it really helps me out and helps produce a lot of this content, and I would be greatly appreciated if you either look down in the below description or in the links. Without the support of my patrons, these type of content would not be possible. And as always, stay safe, keep learning, and I'll see you next week.